Hello students, today in this video we are going to see the aromaticity order of heterocyclic compounds. It is very important question and it has been frequently asked in CSIR net gate and also in IIT-JAM questions. Okay, so we have already seen the aromaticity of Furan, Pyrrole, Thiophene, right? All these three are aromatic compounds. So, how to find out which is most aromatic and which is least aromatic? See, we have to arrange the order, okay, among these three, which is most aromatic and which is least aromatic. So, for this, I am going to tell you a concept. Aromaticity is inversely proportional to electronegativity, okay? Aromaticity is inversely proportional to electronegativity. What is electronegativity? It is the tendency of an atom to pull the electrons towards itself. Okay? It is just withdrawing electron. So that is what is known as electronegativity. So among these three, that is nitrogen, oxygen, sulfur, which is more electronegative in nature? It is oxygen, right? See, in the periodic table, nitrogen, oxygen, sulfur. It will be like this. Electronegativity order. Here, along the period, electronegativity increases and down the group, electronegativity decreases. Correct? So, which is more electronegative? It is oxygen. Then comes nitrogen and then finally sulfur. So, the order is oxygen, nitrogen, sulfur. This is electronegativity order. Okay? This is electronegativity order. So, this is what is electronegativity. If I am saying like electronegativity is inversely proportional to aromaticity. Okay. So, aromaticity order. This is electronegativity order. Aromaticity order will be like thiophene is the most aromatic one. Then comes pyrrole. And then comes furan. Okay, it is very simple, but this is very important concept also, right? This question has been frequently asked in all the examinations. What is the reason? I have told you that aromaticity is inversely proportional to electronegativity, but why? So, why means, see here. This is what is most electronegative and this is the least aromatic one, right? And sulfur here. See, oxygen is more electronegative in the sense it will try to pull the electrons towards itself, right? So these lone pair of electrons, it will try to pull towards itself. If it tries to pull the electrons towards itself, then it will not involve in conjugation, right? See, this lone pair of electron is pulled towards oxygen atom. Then it will not involve in conjugation. If it doesn't involve in conjugation, we will not have aromatic nature, right? Because the basic rule is it should have conjugation of pi electrons. But here, due to the electronegativity, oxygen lone pair of electrons will be pulled towards oxygen atom and hence it doesn't involve in a conjugation and hence it is least aromatic in nature. Similarly, see here, this thiophene, it is not electronegative. If it doesn't have electronegative nature, least electronegative, right? So comparatively among these three, it is least electronegative one. So it will not pull the lone pair of electrons towards itself. It is free, okay? If it is free, then it can involve in conjugation, right? This lone pair of electron also involve in conjugation. If it involve in conjugation, then it will be more aromatic. So this is the concept behind that rule. Aromaticity is inversely proportional to electronegativity. And hence we follow that order, okay? That is why oxygen is least and then comes pyrrole and then comes our thiophene. Okay, I hope you would have understood this concept. Okay, so this is what the aromaticity order. Then what about this is between 5-member ring, right? Then what about the 6-member ring? 6-member ring, here I am going to tell you another trick. Like 6-member ring will have more aromatic nature when compared to that of the 5-membered ring. Okay, just keep it in your mind. 6-membered ring will be more aromatic than that of the 5-membered ring. Now, if I am suppose giving like benzene, okay, this is benzene, then comes pyridine, then thiophene, then pyrrole, at last furan, okay, at last furan. So what will be the aromaticity order? It will be like this. These three we have seen the reason. What about these three? See, I have told you 6-membered is more aromatic than 5-membered, and hence, but among these benzene and pyridine, how we are saying that benzene is more aromatic than that of the pyridine? Among the benzene and pyridine, how we are going to justify the answer that benzene has more aromatic nature than that of the pyridine is, nitrogen is electronegative atom. See, all the other atoms are carbon. These 5 are carbon, and here also. But here it has carbon, here it is nitrogen. Now which is more electronegative? Nitrogen is more electronegative, right? If nitrogen is more electronegative, it will try to pull the electrons towards itself and it will not have proper conjugation. As a result, it will be less aromatic. Okay, but here it is carbon atom. It is not, this carbon to carbon is not much electronegativity difference is not there, right? And hence, it can involve in conjugation. If it involves in conjugation, then that particular compound will be aromatic, okay? Hence, benzene is more aromatic when compared to that of the pyridine, okay? So far, we have seen the aromatic conditions and then we have seen examples, and in this video, we have seen the aromaticity order. In the upcoming videos, we will see these homoaromaticity, quasi-aromaticity, these concepts, and we will try to solve the previous year questions in the next video, okay? So far we have seen the concepts. At last, after completing all the concepts, we will try to solve the previous year questions. Stay tuned. Thank you so much for watching.